All right, so I'm just going to make a lesson here, or a video lesson for introducing the beginning part of Chapter 8, which primarily has to do with quadrilaterals. But in this section, 8.1, we're going to find angle measures in polygons. Remember, poly means many, gons are like sided figures, definitely Latin-ish, I guess. Anyway, just to recap the definitions that you guys were supposed to do over the weekend, a diagonal of a polygon is a segment that joins two non-consecutive vertices. So if I say, like, I draw all the diagonals from vertices A, so A to C is a diagonal, A to D is a diagonal, okay? Then I can draw all the diagonals from B. B to E is a diagonal, B to D. And then all the vertices from C. The only one that I don't have drawn is from C to E. Okay, that is all of the diagonals in this particular polygon. On the top of your notes paper, we have this formula thing that's really important. Okay, the sum of the interior angles. Okay, this is the sum, so that is the total of the interior angles. If you want to find each interior angle, we simply take the sum and divide by the number of sides. That will tell us each angle, given that it's regular. Remember, regular means that it has the exact same measure for each angle. And all the sides are the same length, too. All right, so now we're going to investigate some theorems, okay? We're going to try to find how many triangles we have in each of these figures. So we're going to draw all the diagonals from one vertex. So I'm going to mark that vertex with a red dot here. I'm going to draw all the diagonals from these red dots. Okay, so with this first I can't draw any diagonals. Those are already sides. So I have one triangle here. If I draw all my diagonals, I can only draw one, which separates this polygon into two triangles. Here I can do 1, 2, separating it into 1, 2, 3 triangles. All right, and my last one, all the diagonals from my little red dot here, so that's 1, 2, 3 diagonals, separating this into 1, 2, 3, 4 triangles, okay? Why do we care about triangles? Because we know what the interior sum of a triangle is. So using the number of triangles to determine polygons, total sum is really important, okay? So first off, here's our fancy little chart we're going to fill out. The number of sides are n, right? The number of triangles are n minus 2, right? So we take the number of sides minus 2, that'll tell us how many triangles there are. Then for the sum, that was the formula you had in the beginning, so n minus 2, all of that times 180. For this is just one angle. This is n minus 2 times 180, all of that divided by n, the number of sides, okay? So in the beginning, it's pretty simple. You're like, oh, I know, a triangle has 3 sides. It is one triangle. The interior sum is 180 degrees. The measure of each angle, because if it's regular, is 60. Quadrilateral has 4 sides. Number of triangles, 4 minus 2, so 2 times 180 is 360 degrees. 360 divided by 4 is 90. Pentagon has 5 sides. 5 minus 2 is 3. 3 times 180 is 540 degrees. 540 divided by 5 is 108. Hexagon has 6 sides. 6 minus 2 is 4. 4 times 180 is 720. 720 divided by 6 is 120. So each interior angle is 120 degrees. A heptagon, that has 7 sides and 5 triangles. Therefore, the interior sum is 900, because 5 times 180 is 900. 900 divided by 7 is a decimal. We're going to round 128.6. This is the only bizarre one, but I mean, it's a heptagon. Like, really, how often do we come across those? And we have an octagon, which we know is 8 sides, 6 triangles. 6 times 180 is 1080. Divide that 1080 by 8 and get 135 degrees. All right, nonagon, that's 9 sides. 7 triangles. 1,260 degrees is the sum. Divided by 9 gives us 140 for each angle. A decagon has 10 sides. 8 triangles. A total sum of 1,440 degrees. That divided by 10 is just 144 degrees. Then we have a dodecagon, which is 12. 10 triangles. 1,800 degrees. Divide that by 12 and get 150 degrees. Now we have this thing on the bottom, n-gon, where n represents the number of sides. So it has n sides. N minus 2 triangles. N minus 2 times 180 for the total. Now you might want to write really small because I need to take the total, n minus 2 times 180, and divide all of that by n to find out what each angle is. Now let's look at some examples here, okay? So first off, let's figure out what the sum is. I have 1, 2, 3, 4, 5 sides. 5 minus 3 times 180 is, what is that? It is 540 degrees. So the interior sum is 540 degrees. Do not forget this little box here. This little box represents an angle measure, 90 degrees. So 540 minus 102 minus 90 minus 141 minus 83 equals 124. So that x is 124 degrees. Let's look over here. We have 1, 2, 3, 4, 5 sides again. So the interior sum is still 540. Now our angles are given in expressions. So you want to take your expressions and combine like terms. Add all your x terms together. 6 plus 7 is 13, plus 8 is 21, plus 4 is 25, plus 10 is 35. So that gives me 35x. Now I'm going to take my numbers and add them together. 4 plus 4 is 8, minus 4 is 4, plus 8 is 12, plus 3 is 15. So 35x plus 15, all of that equals 540. And I'm writing 520. I'm not quite sure why. Okay, subtract 15, divide by 35, and we get x is 15. All right, that's all well and good, but I need to plug that back into all my angles. So 7 times 15 plus 4, 109. 8 times 15 plus 3, 123. 4 times 15 plus 8, 68 degrees. 10 times 15 minus 4, 146. 6 times 15 plus 4 is 94. Okay, so combining my terms, setting it equal to the sum, and solving for x is very simple. You should all be able to do that. All right, let's look and see what else we got here. So I have a 1, 2, 3, 4, 5, 6-sided figure, right? 6 minus 2, all of that times 180. What does that give us? It gives us 720. So this has an interior sum of 720. Simply take your 720 minus 146 minus 156 minus 91 minus 135 minus 118, and we get 74. So this is 74 degrees for x. Easy peasy lemon squeezy. All right, now we're going to talk about the exterior angle theorem, please. This is very simple, but often overlooked, okay? The sum of the measures of the exterior angles of a convex polygon, so any convex polygon, the sum is always 360 degrees, okay? Another thing to note, the interior and exterior angle form a linear pair. Kabushki. So if we know the outside is 72, 180 minus 72 will give us that interior angle. The measures of each exterior angle of a regular n-gon is 360 divided by n. So in this case, we have 360 divided by 1, 2, 3, 4, 5. That gave us 72 degrees. All right, cool. Facts. No matter what, outside, no matter how many sides it has, no matter how big or small it is, exterior angles will always measure to 360. So octagons, pentagons, hexagons, they all have the same exterior sum. It's all 360 degrees. All right, let's fill out this little chart. First off, you have these formulas on your paper, so you should be able to do this a little better than me. I wasn't able to fit this all on one screen. So first, when we have the number of sides, you take that minus 2 times 180 divided by the number of sides, right? So minus 2 times 180, all of that divided by n will give us the interior, which is 108. Interior and exterior are supplementary, meaning together they equal 180. So 180 minus 108 is 72. And I am sorry, my pen is moving out right now. I don't know what's happening. All right, total interior angles, we already did this, right? That is simply 5 minus 2, all of that times 180. 5 minus 2 times 180 is 540. 540. Okay. Cool beans, okay? Remember, these guys are a linear pair. If you have one, you can easily find the other. Remember, linear pairs equal 180. So if this is 20, that means this is 160. When you really need to know the exterior angle if you don't know the number of sides, because we simply take 360 divided by 20, and that's going to give us 18. That's how many sides this polygon has. For the total sum, 18 minus 2, which is 16, times 180, that gives us 2,880 degrees. Okay, remember, interior and exterior are supplementary. 180 minus 135 gives us 45 degrees here, okay? To find the number of sides, you simply take 360 divided by your exterior angle, and that will give us 8 sides here. And for that one, go 8 minus 2 times 180. 6 times 180 gives us 1080. All right, the last column is obviously the hardest because we always save the best for last. But don't worry, it's not so bad. We simply take our total interior angle equation, excuse me, which is n minus 2 times 180, and we set that equal to it. All right, we're going to use inverse operations to solve for n. So first thing I'm going to do is I'm going to divide by 180. And I get n minus 2 equals 28. And I'm going to add 2. Don't forget to add 2. N equals 30. Okay, so this is 30. Okay? To find each interior angle. 5,040 divided by 30 will tell us what each little angle is, which is 160 degrees. You could either subtract from 180, 168, or you can take 360 divided by 30, and that will give you the same thing, which is 12. 12 degrees here for the exterior angle for a 30-sided polygon. All right, cool. Well, here's your homework. Make sure, see, I told you I couldn't put the formulas on that same page. Here it is, assignment number 41, numbers 3 to 21, and 24, and 26. Pause the video if you need any help. Make sure you ask questions on Schoology, or in class, or whenever, if you're ever confused, and have an awesome day. Bye.